Welcome to another episode of the Cloud Architects Podcast. Today, by intention, it's going to be rather interesting. We're going to throw some definitions of things in that sometimes we've always wondered what they actually mean and what they're about and why is it always this thing. It's an episode about DNS. But before we go there, let me just acknowledge Chris in a freezing Australia. Hi, Chris.
Yeah. Hello, how you doing? Good to see you again, Nick. I'm excited to be here. It is unseasonably cold, actually, where I am at the moment. So, winter time for us here in down under, anyway. And what's interesting about this particular episode? So, firstly, Nick is the designated adult for this episode. But moving beyond that, what makes it quite interesting is this actually spawned out of a conversation that our guest Robby and I had after our last episode. So this is essentially a part two, but we are wearing different outfits to what we were in part one because
yes, we have washed since that last episode.
A few days have passed, or at least a couple of weeks have passed since we recorded that last one. But we, when we were off air after the last recording, we kind of went down a rabbit hole of just chatting amongst friends and this sort of topic of DNS and why we always blame DNS and how DNS is helpful and can also be a real hindrance, right, for us. And so we figured, it really deserves some public airtime. And so we thought we would have another conversation. So we welcome Robby back. Robby Pedrica, thank you again for joining us from Cape Town, I think, is where you are. So really appreciate you joining us. You had that much fun last time that you decided to come back for the very next episode.
Chris, thank you for having me on your show again. Yes, we also pretty cold here in Cape Town. And I'm looking forward to this episode of DNS. It's a fascinating topic. So, yeah.
If you are watching this on YouTube, you'll notice that Robby and I are both wearing a second or a third outer layer. I'm wearing my puppy jacket because just as cold for me in Cape Town. For our American friends, we acknowledge that we are not as strong as you, and we bow down to our Canadian friends who are able to live life in sub-zero temperatures for months and months. For us in Cape Town, it's cold if you think in Fahrenheit. If you think in Celsius, when it gets to 3 degrees, we're all pretty miserable, and we think it's a really, really cold winter.
Yeah, that's about 38 or 39 Fahrenheit, I think, something like that. I just returned from the US. I was in the US a couple of weeks ago, and I spent some time in Arizona, and it was like 117 Fahrenheit, which I think is kind of mid 40s Celsius, right? It was pretty warm.
That's good proper temperatures there. I'm going to kick us off, and this may be a little bit more of a technical episode, but we know that our guests are able to track with us. But just for the sake of staying out of acronym soup, we're going to try and define the things as we go along. And we'll just start with talking about what DNS is and why do we even care? Robby.
Nick, the main name system or domain name service, whichever one you prefer, back when the internet started with DARPA, they came up with this wonderful IP addressing scheme to identify every individual and unique node on the internet, on the network. But trying to keep track and recall all of those IP addresses is impossible. There's billions of them. So they came up with the domain name system, DNS, which is you can think of almost like a post box. It's a named address for some service or system on the internet. When you refer to a host name on your endpoint, a browser, email, it converts the domain name or the name that you've specified into an IP address in the background. It's something that you don't need to worry about, because it's all done automatically. And it's much easier to remember domain names and URLs and that kind of thing. So, yeah, that's the basics from a client point of view.
Nice.
And you say you don't have to worry about it until it goes wrong, right? because that's when we do have to worry about it, because ultimately, you know, there's so much hangs on this, right? And interestingly, and this is a slight tangent, so Nick's going to hit me with a stick in a second, but have you guys been following sort of Google and their new top-level domains with their .zip top-level domain, which is obviously causing all sorts of chaos on the internet with .zip. I don't know why anyone thought that was a good idea, but
just to do some commentary on why .zip is a bad idea, because it sounds like it's innocuous, but from an attack point of view, it's actually rather opportune. Do you just want to unpack that for a second?
Yeah, sure. I mean, look, I think being able to fool or trick or users into clicking things is obviously the number one tool in the tool belt of any bad actor, right? If you can get someone to click a link or click some malicious thing, then you can potentially action something, which again could gain you a foothold. And I think this is just, it gives them another feather in their cap as far as being able to trick users into potentially clicking something that they think is a file, but actually is not a file and is actually going out, out to the internet. What is kind of scary, and I know Safari on the Mac does this, I don't know any other browsers or on Windows, but if you have this option which is enabled by default on your Mac, if you download a zip, it will automatically unpack it for you, because it sees it as a known file type. So I can only imagine that there's some way that you could use that capability right to your advantage if you're trying to fool the user into doing something. I haven't thought about trying to design some payload for it, but I can only imagine that can be used to trick a user. So it can cause all sorts of chaos with it. And what's been really interesting, and I read some research on this last week, and actually seeing some examples of how you could fool a user, right? By, just for example, adding an @ symbol into the URL, you can turn,
that's right,
a GitHub URL into an actual a URL that is actually pointed to some .zip. So instead of downloading something from GitHub that has a .zip file extension, you're actually sending the user to a URL that ends in .zip, which, it's a whole different issue. So there's been a lot of strong opinion and strong guidance online about, blocking all access to the .zip namespace, right? And I think .mov is the other one, probably not as dangerous as .zip. But where this, I think, gets really comical is that Google have announced that they're shutting down their DNS domain name registrar, right? Which is kind of sucky, because I have like 35 domains registered with Google, and they're selling all that stuff off, I think, to Square or someone like that, Squarespace, something like that. But I thought it was quite comical that they came in, they threw a grenade into the industry, and then after that they're like, okay, we're out, and they're stepping away from it. So that was the point I was gonna make with that.
Do you know
it's typical? Yeah, it's typical Google. I mean, we can probably count with the number of IP addresses on the internet, the number of services that Google has retired. So, I want to add on to Chris's portion there to say that IDNs, or internationalized domain names, is an offshoot of this particular problem. Because you can use alternate language sets to make URLs. It doesn't have to, there's nothing that says it has to be in English. So if you take something that's Chinese, for example, Eastern European, you can end up with all sorts of characters in the name, in a domain name. And this presents additional problems beyond just the obvious URL that Chris has just mentioned. For example, github.com or github.com.zip, for example. So IDNs are a huge issue, especially for end users who have no idea what's actually happening in the background. And they can't even see in the URL, because there are characters that look like normal characters to them, but are different. And they could point to somewhere else than where they expect to be going. So, it's a huge problem.
One of the more interesting attacks, and it's such a basic attack, but I think it would fool just about everyone who would look at it in the plain light of day. If you look at the alternate character sets that look like an A, but actually aren't a lowercase a, and you think of the name bank, and you could register any bank's domain name as a .com or anything really, and it wouldn't be the same one, and it's very easy to create an attack platform out of that. And the defense against that is really simple. Never click on anything that you don't type into your own browser.
And there's an addition to that, of course, is because SSL certificates are bound to the domain name. So they do perform some sort of check to compare the domain name against a formal or official SSL certificate for the site that you want to go to. So that's important to check as well.
Yeah, what's interesting, I guess, and one of the reasons I guess why Chrome is moving away from the little padlock, right, is because the padlock itself is useless for users anymore. Because we used to always tell, I mean, I don't know about you guys, but I used to always tell my parents, like, make sure if we go to the bank site that, there's a little padlock down the bottom there. Well, with things like Let's Encrypt now and free certificates being pretty much readily available, it really doesn't mean much anymore, because a good malicious actor is gonna have a certificate on his phishing page or on his phishing site anyway, right? His or her or their page. So that doesn't really help much at all. And I think that's another reason why password managers are such a good idea, because password managers are only going to allow you to paste in your password into the legitimate site. So if someone is using some sort of typo squat attack where they've used the Unicode character to replace the A or something like that in a URL, your password manager is not going to fall for that, even though your eyes might. So another sort of really good use case for password managers. But I think these are all sort of ways where I think DNS can be really essentially used against us, right? To fool us or trick us, or something simple can really be used to cause sort of a lot of issues. But Robby, I know when we talked about this previously, this was something that you were quite passionate about, and you had some really good thoughts on, maybe ways to secure DNS, right? Because I think one of the other challenges we find is that because we've all been using DNS since the very beginning, if you will, not much has changed for many, especially for many organizations, right? They set up the Windows DNS server role now. They make sure that it can get out to do the its referred lookups or whatever, and that's it. We've got DNS. Why do we need to change it? But really, outside of securing those sort of zone transfers, like, there must be a better way for us to use DNS, or a more secure way for us to use DNS, isn't there?
Well, this is a huge topic, and it all starts around DNS architecture. And we really need to split DNS into two parts. The first part is the server part, or the upstream part. And the second one is the client, how the client deals with DNS lookups. We do a lot of testing in this regard. And just to add on to your earlier topic on URLs that might point elsewhere, is we've tested all the mainstream browsers recently, and Firefox came out as the only browser, client-side browser, that would notify the end user if there was an issue, or if the browser thought there was an issue with the URL that the end user was inputting into the browser, which is quite interesting. And that starts the process of client-side lookups. Remember, we've got an operating system on our desktops, our laptops, our iPads, all our phones, etc. This is the client in the client-server transaction that we do when we're doing DNS lookups. So we need to make sure that we secure the client side of things. Absolutely, you can't just look at the network and upstream. We can go into that more detail later on. But the upstream portion is probably the most important part, because the upstream portion could be exposed to the internet and might be vulnerable in terms of the responses that it's getting to DNS queries. So the architecture or the topology of your DNS setup, especially in corporates, I'm not really referring to home users here, but especially for corporates, is critical to securing the DNS process within an organization.
I mean, that's really interesting, right? And I think, we've all been in those sort of large environments where, you know, you kind of change or chain your resolvers so that you have, you know, some publicly accessible ones that kind of are responsible for internet resolution, and then you have your internal ones that are internal facing, and you really don't allow you know, anything else but those to talk to each other. But I mean, what else can we do? Where do we go on top of that?
Well, let's talk about the flow of DNS queries quickly, because that will sort of lead us in terms of what we need to do. So the end user device does a DNS lookup for any internet-based service. So there's a domain name, a host name that needs to be looked up. The end user, the client, is configured with an upstream DNS server that it needs to query. It could be in a corporate environment, a Windows Active Directory server. It could be some sort of other DNS server. And these DNS servers are called resolvers because they resolve DNS queries. They, in turn, can either speak to what's called a forwarder, which is a DNS server sitting on the internet, or they can do something called a recursive or iterative lookup on the internet, where they go to the source, the authoritative service for that zone, the domain name zone, and then provide a response in return, which comes back down the chain to the client. So the architecture of that is important. So in terms of security, we've sort of come up with a couple of options in the last few years. From the client side, we have two new features called DOT and DOH. That's DNS over TLS and DNS over HTTPS. Now, these two protocols are designed with privacy in mind. And privacy is critical in the DNS system, because if your queries are intercepted by a third party, a malicious third party, they can make use of that to build a profile of what you as an end user are doing on the internet. And profiling end users is the start of open source intelligence gathering, you know, finding information about a target that you want to attack. So the privacy of DNS queries is very important. So DOH and DOT were designed with this in mind. I won't go into the details of the protocol, but essentially they just encrypt your DNS queries. Now there's a big downside to this, because if you as an end user are encrypting your queries, especially in an organization, your upstream network services cannot see what you are querying as well. Okay. And in terms of network security implementations for controlling what you can and can't do on the internet, otherwise known as DNS filtering, that obscures your DNS queries completely on the internet. So, you know, especially DNS over HTTPS, because it makes your DNS queries look like normal HTTPS traffic, it's extremely difficult to control on a network, because devices typically can't see the difference between a normal secure HTTP lookup in your browser versus a DNS query that is running over HTTPS. And from a privacy point of view and from a security point of view, that is an actual issue. So I always recommend that home users use a DOT or DOH, but corporates actually need to outright block it so that they can actually inspect the queries from the end users.
There's another upside to that, Robby, from not just from a privacy point of view, but let's turn it around back into an attack point of view, and how DNS can be abused for a man-of-the-middle attack.
Yeah, so there's a huge amount of attacks that are available or applicable to DNS as a protocol. And, you know, man in the middle or DNS poisoning or DNS spoofing, that you know, these are a collective bunch of terms for the same or similar type of attack, is where the information that comes back to the client from a query, the response, is tampered with in some way. And the idea is to redirect the end user to somewhere else than where they were initially intending to go. And obviously that's bad. An example of this is you might be going to your bank's website to perform internet banking. And if you are redirected, you could be redirected to a different site, a malicious site that looks exactly the same as your banking site. You would enter your credentials on that site. The attackers would gather your credentials and then redirect you back to the real banking site. The attackers now have your credentials in the background for them to use whenever they want to. DNS spoofing, DNS leaking, all hijacking, all this sort of subset of attacks are very similar, and they present a real issue on the internet. And we rely on systems security systems to provide us with mechanisms to protect us as end users around that. I'll give you two examples of that. For home users, you could potentially use an upstream DNS service like Cloudflare, who has a number of different classes of service. For example, their Quad 1 service is completely open with no protection on it. Their 1112 service is a DNS service that provides protection against malicious class of sites. And their 1113 service is, for example, something that you can regard as a family filter. And a number of other providers provide similar sort of things for the end user. On the corporate side of things, we want to use DNS filtering devices or software to probe the query, and this is why those systems, it's important for them to see into the query, see what you are querying, because they can use then their malicious DNS databases to say, first of all, this is the category of query that you're trying to do. It's a banking query or it's a social media query, etc. And secondly, the actual site itself and whether there's some sort of problem that has previously been reported on that site. For example, it's a malicious site. The network intelligence or the network security can then block the query as your organizational policy configures. So
I have a problem with that, Robby. And while I have no issue at all with securing what comes out of my home network, as a person who works from home as well, if I use an 8.8.8.8 or a 1.1.1.1, it breaks stuff. And especially when I want to use my cloud services. So one of the issues that we've got is that if we look at the best practices for how to use cloud services and the networking configuration that's attached to that, is we need geographic location services, which is part of DNS, to find the closest instance of the cloud that we are trying to use. And we find that our hyperscalers that we use spend millions and billions of dollars to ensure that they provide a network node or a front door as close to us as possible. So I hear you from a security point of view, and I completely acknowledge that. And then from a work from home point of view, that breaks down altogether, because now in South Africa, as an example, I could be forced to use a front door that's in the UK. And in the US, you might use a front door that's in another state or 100 milliseconds away. So how do we balance that?
Yeah, so I'll give you a solution to that from a corporate point of view. And this goes to even if you're working from home as a corporate user. So the last few years, we've been working on architectures, especially corporate and organizational architectures for DNS layouts. And there's two parts of this. First of all, if you're working from home, you're typically a remote office worker and are connected to your organization through some sort of method. It could be a VPN, a newer ZTNA technology, etc. But the point is that the organization's configuration should be such that when you do a DNS query to an organizational service, that should run through your remote connection. And when you do a query for an internet-based service, then that should run through your normal ISP or whatever DNS service you normally use. By forcing or routing your organizational DNS queries through the organization, you can then control the upstream routing of traffic. And this is where it comes to the second part of this, the upstream or the server configuration. So yes, typically we spoke about earlier an organization using upstream services like Cloudflare, Google DNS, etc., Quad 9. However, that is not optimal, and it's certainly not secure or privacy enhancing for organizations. So the best is actually to run something called a recursive or iterative server in your organization. What that means is that the query will go to the authoritative source for the domain. To expand on that, there's a server out there for every single domain on the internet. If we take, for example, google.com, google.com has a number of authoritative servers that serves up the DNS records for that zone. Okay, that is the originating source for that domain, google.com. So recursive or an iterative server is going to go to that source and get the actual answer, the original answer for your query. And by doing that, you can be assured, along with another DNS extension called DNSSEC, that the answer that you're getting is the original answer, it's the correct answer. And then attacks, like we've spoken previously about, DNS spoofing, hijacking, etc., can no longer take place. So the problem of CDN services can then be resolved in the recursive or the iterative server via a number of mechanisms. One of them is called ECS or eDNS client subnet. And essentially what this do is this looks at where you as an end user are coming from, your IP address and the geographical location of that IP address. The recursor can then route your query to the CDN service in such a manner that you will end up at a geographically local service for that CDN that gives you the best performance. And that is the task of your recursor and that function called ECS or eDNS client subnet.
So you've brought up some, I guess, really interesting things that I haven't thought about yet. Like I've never considered the reason why you wouldn't just completely take over your DNS within your org, right, and just use your organization and just go with a privacy friendly encrypted way of doing it. But what you said makes perfect sense to me, is that you want to be able to look into those queries so that you can understand if anything bad is happening, right? And of course, it's always easier to go, oh, well, you got 3 or 4 machines, you kind of know what's going on there, versus 300 or 400 or 3,000 or 4,000. Like all of a sudden, then you really need an automated process that can look at that stuff and detect any nasties. But I do like the whole privacy of DNS. I think is really, really important, because I think for some of us, for a lot of us, we work from home, or we spend most of our time working from home. At least I think many people are in that boat now. And not all ISPs all over the world are friendly, right, when it comes to that, because they want to be able to, they actively spy on what you do, because they want to be able to sell you stuff, or they want to be able to do. So one of the really interesting example of this is, when I lived in the US, and I first got my fiber line installed, the router was set up with the standard, Verizon DNS services, right? And I quickly learned that they were injecting, via JavaScript, they were injecting ads into my searches and stuff. So like if I hit a web page that didn't exist, right, or a name that didn't exist, I would get directed to some random page that had an ad, which was injected by then. And it was a really kind of big wake-up call to go, hey, hang on, like DNS is actually quite a precious thing, and the information that, by default on, UDP 53 that is available to someone actually looking at it, there's a lot of rich information there about my habits, my browsing habits, websites I'm going to, the shopping site, all of that stuff. And so I think, like, at that point in time, that was a big wake-up for me to go, hey, like, I got to start kind of paying attention to this a little bit more. But I also then discovered that there are these amazing things available on the internet called block lists for all of the, companies that serve up ads in on various things. Now, you can get into the sort of moral discussion about ad-supported websites, and I know everyone that develops content has some sort of stance on this, right? My stance on it is that if I want to use a service and the service is valuable enough to me, I will pay the service. I will pay them for their service. And I'm not a fan of just 1,000 ads on every website that mostly just messes up my interaction or experience of the page. And so I'm very harsh when it comes to that. Like here, any ad gets blocked. And if I get to a site and they're able to pick up that I'm using an ad blocker and they won't give me the content, then I'm sorry, that's it. I'll see you later. I'm not going to go there, right? Because we've gotten to the point over time now where ads on the internet are so intrusive and so annoying.
We're fed up.
Yeah, well, exactly, right? I'm almost at that point with cookie walls now, but I don't know that there's anything I can do about cookie walls, right? But it is what it is. And so what I do is I used to have a Pi-hole. I think everyone's familiar with what Pi-hole does, but essentially it's a DNS server that you can run in your own network on a Raspberry Pi, and you can give it some block lists, and so it will block known ad services. And what's nice about it is it obviously gives you your own internal DNS resolution as well, right? But I don't use a Pi-hole anymore. I found something called AdGuard, which is it's very similar. In fact, it's, I think, a little bit more polished than Pi-hole is. But it does allow me to, Nick, as you were saying before, it allows me to have certain forwarders for certain addresses within my network. So, if I'm forwarding everything to Cloudflare, for example, right? But I have one specific thing, and in my case, it's my Apple TV that I want to have forwarded somewhere else for DNS resolution, that will allow me to do that. So it can handle that for me. So that's a really, really cool thing. But it also at the same time gets rid of all the ads. So yeah, I guess the point I'm kind of getting to here is it's interesting that we can treat, and maybe we should treat, like the use cases for home and for the things that we do at home a little bit differently to the use cases for what we would need in a business or corporate environment, because ultimately we're using those tools for different things, right? And we want to protect different types of information on that, if that makes sense.
Two comments, Chris, just to add on to that. First of all, I think services on the internet have abused us as end users to no end with regards to cookie tracking, advertisements, etc., for so long, to an extent that most people aren't even aware that using ad blockers, I have no moral issue using that because I know what's going on in the background, and I know what the third-party trackers are doing to us as end users. They are completely abusing us, and I think we need to protect ourselves as end users. So.
Yeah, and the thing is, I think we live in countries, us three, where probably we have a little bit more protection, or at least awareness of this. There are other countries where it's a free-for-all, right? Or the laws are not necessarily as, user empowering or on the user side as possible. So it's a really weird thing. But what's fascinating is that, Carmen, my wife, gets really upset now when she's not on Wi-Fi because she's browsing her phone, and all of a sudden, what happens is it surfaces in games for her, because she's always playing some like a Candy Crush type game, right? Now, when she's at home, obviously no ads are served during the game, so she can play along and it's quite fine. But then when she goes somewhere else, or if she's like at some family's place and she's playing her game, all of a sudden she's getting ads that float up in the middle of the screen and disrupt her user experience. And she's always like, I can't believe these ads. And it's one of the benefits, I guess, of being on Wi-Fi versus when you're not on Wi-Fi and all of a sudden you go into the big bad world. No more protections, right?
Controlling your network.
Yeah.
So Nick, Chris, I'd like to continue in terms of the architecture. We discussed the two parts initially, the client side and the server side. But there's actually a third part to this. So we have the client doing a query. We have the DNS server looking at the result and serving that response back to the client. But where do all these domain names live? How do they come about? And this is done via something called a registry. And there are regional registries around the world. So for example, here in Africa, we have something called Afrinic, which runs the registry for all the African domains, for example, .cm, .za, .ma, etc., all those what we call top-level domains. So when someone needs to have a presence on the internet, they need to purchase a domain name, for example, google.com, and that needs to be registered with a registry. And for most people, that process occurs through someone called a registrar. And a registrar is just a middleman that facilitates the process of registering the domain name with the registry. These registrars typically make use of a piece of software, sometimes an API, that helps end users register domain names. And a very common mechanism is called EPP, or Extensible Provision Protocol, which assists in providing a common platform or common mechanism to register domains, transfer domains, etc. So I'll just mention from a security point of view, a company called Hack Compute recently did a review of registry software, EPP-based registry software. And it was quite interesting that they got to the point quite easily where they found vulnerabilities in the software and could completely take over the management of top-level domains at the registry level, okay, and therefore do anything. They could delete a domain, they could add a new one, create false records, change existing records. And the implications of that from a security point of view is very bad. They've obviously worked as part of their research with the software providers providing this registry software to fix those vulnerabilities. But this does bring into consideration, especially for corporates, an aspect of DNS that is rarely considered, and that is the upstream hosting, management, and registration of DNS domain names. It's a critical part of most organizations' business, but it's seldom looked at. And I think it needs to be given greater weight.
So that's a very interesting point, right? And I didn't know about this research. It's kind of scary if you think about it, that your whole domain name could just get taken over. And it's obviously a lot worse than just leaving your AWS account open and having someone mess around with your Route 53 account, right? But so what are considerations if I'm a business and I'm looking to register domain names for myself? Are you saying I don't just go to GoDaddy and just pop in a credit card, or cheap domain names.co.za and here we go? What sort of things would I consider then, or should I consider? Because it just so happens that I'm in the market for a new registrar myself, so it might be useful.
You need to do some due diligence. So in the same way that you might vet the software that you run internally in your organization and follow the vendor's security feeds, those kinds of things, you need to treat your upstream DNS vendor, your registrar, in exactly the same way. And yes, there are a lot of popular registrars on the internet like GoDaddy, Google Domains, we spoke about earlier. However, if you do some research, you'll realize quite soon that a lot of these popular registrars have had security issues in the past, compromises where customer data has been stolen by attackers. So it's critical that you do due diligence in terms of choosing an upstream registrar to facilitate your either the registration and the handling of your DNS records, or the actual management of the hosting of those records as well. Very, very important.
Yeah, wow. Good tip. Something to think about for sure.
I'd like to talk about abuse for a little while longer. And
Abuse me, Nick. Abuse me.
well, Chris, it's not that special time of ours, and there's no safety word here. But I do want to talk about a safety word when it comes to DNS and denial of service attacks. And they were really, really popular for a while when we had, I don't know, Robby, can I call them malicious ISPs that were participating in these type of things? And it really is a sordid world out there when you've got enough money, or actually not even a lot of money, to craft an attack. And in the press, we'd see a denial of service attack against an ISP or a large label, and it appeared that they were at the mercy of attackers, and there was always another DNS attack coming out that had something to do with denial of service. But denial of service isn't just about creating a large amount of traffic to shut something down. There's a lot of craftiness that could come into a denial of service attack that comes with DNS.
Yeah, absolutely. And, this is one of those attack methods that can be used against DNS specifically. And this is why the architecture that we spoke about earlier in terms of how you set up your DNS, especially in corporates, is critical to maintaining a secure system. If you can take control of your own DNS queries and have nothing upstream in the path, then that removes a lot of attack methods, out of the story. It really makes a huge difference. And, when we look at denial of service specifically against DNS itself, we'll see that the sources of those come mainly from, SaaS services for bot attacks. It's crazy that we're calling, that we have something called DNS denial service as a service these days. But these services exist, and they're freely available, and you can subscribe as a an individual attacker and then attack someone. But besides those attacks as a source, the other main source for DNS attacks, especially what we call amplification attacks, comes from compromised network equipment, especially home routers. And we see, for example, an attack mechanism called the Mirai botnet, which has been around for quite a number of years now. They keep on adding to their toolkit in terms of the attacks they have. And many of the attacks that they have focus on compromised edge networking equipment, home routers, business routers, that kind of thing. And
Wow.
Mirai at one point in time had a botnet arsenal of close to 30 million devices, and strange enough, many of them in specific geographical locations around the planet, because of the type of equipment that some ISPs use in those countries. South America, Brazil has been a great source of DNS amplification attacks because of the type of equipment that the ISPs use there and the vulnerabilities that equipment has. So once again, if we are corporate, we want to take complete control of our DNS system and potentially use recursors to get the original source response to our queries. As home users, we can either go the route of a solution like Chris has mentioned, a Pile solution, AdGuard, etc., or use an upstream DNS server that has the capability to block denial of service attacks. I'll mention, I don't like bringing in brands, but Cloudflare as an organization has a history of being a great company that provides protection against large volume attacks. And if you make use of their upstream DNS services, then that service itself is protected by them against high volume amplification DNS attacks. So once again, it comes back to due diligence. doing some homework and making sure that the vendors you use upstream have the capability to do what you want and have a proven track record of doing what you want. Highly critical as a home user or a corporate.
Yeah, I would say, look, I'm a big fan of Cloudflare. It's a service I've been using for a long time for, websites, domains, all sorts of stuff. They really have a really good service, and they're very generous with what they give you for free as a free user. I would say. But I want to just plug as well, because I think people might be interested in this, and it's not a plug because there's nothing in it for me, but I've been recently testing out and using something called NextDNS. So I think nextdns.io is their website. And essentially it's a cloud hosted Pi-hole, basically. And so what's great about it is that there's an iPhone app, for example, that you can install on your phone, and when you click a button, it will pass all your DNS traffic to it. Really good for being able to, you can monitor obviously what's going on, what sort of things your devices are doing, and has a lot of blocking capability and things like that. I've really kind of enjoyed using that, especially when I'm not home and traveling. So just to put that out there for folks, who are privacy conscious at home and maybe don't want to run up their own infrastructure, right? No.
And another offshoot of that is some sort of tunneling mechanism that gets you onto the internet and obscures you as an endpoint on the internet. For example, Cloudflare tunnels is an interesting option. So you could still host your Pi-hole or AdGuard or whatever service you want to use at home, but using a Cloudflare tunnel or a similar service, you could essentially carry that home-based service with you as you travel around on the internet and use other public internet connection points. So yeah, there are a lot of options for home users. Some are more complicated than others. Yeah. But yeah, do your homework and see if you need to try and improve your security.
Yeah. I think we're at a point in time now where you can't just go to your ISP anymore, get a router from them, set and forget. That I don't think that works, right? I think you don't have to be a hardware junkie. You don't have to be installing Meraki or Cisco equipment or Unify stuff like I have over there. You don't have to be doing that at home if you don't want to, but you do have to make sure whatever router you have can be updated, right? If it doesn't do auto updates, you need to look at it, occasionally to make sure that it doesn't have free or new firmware, because, as you mentioned, Robby, all these botnets, I mean, they're taking over these IoT devices, doorbell cams and fridges and baby monitors and things, and they just weaponize them, right? And if when you're going to consider buying stuff like this, possibly the $3 cheap one from China on Amazon isn't the right choice, because it may not have an update mechanism, right? And the IP stack it's running is probably 20 years old and will never be updated. So from a security perspective...
Well, we had a show on that.
We did. Yes. And I might actually link to that in the show notes, just because it's a very amusing video to watch. And I will preface the link with prevent parental advisory, explicit lyrics ahead, warning. But we'll not from us, but from the person presenting. But yes, I think it's important that anything you buy for home these days, you have to be able to update it, right? And then again, I think Robby, as you said, it's important to take control of your privacy, right? No one's going to do it for you, and so things like a DNS service or something like that can help, or tunnel, anything like that. I mean, I think everyone understands the concept of a VPN these days, right? Here in Australia, we have NordVPN ads like on TV. Now, not saying you need to go out and buy NordVPN, but just saying like those are the types of things you should be thinking about, because the internet is just not a safe place anymore, and you can't just put down the tech and just expect connection. And not everyone has access to a tech person on the weekends or after hours, right? Yeah.
Nicholas, Chris, I'd like to sort of delve a little bit deeper and a bit quickly into the DNS protocol itself, specifically something called DNS record types. So, DNS is not as simple as, just putting a URL into your browser and having that resolved and going to the resulting website. there are actually a number of different record types available as applies to, for example, web, email, voice communications, video conferencing, etc. And it's quite interesting that up until this point in time, there are no systems that look at the content of record types for security issues. It's something I've been thinking about for quite some time. And, there's a record type called TXT, or a text called a text record, which can contain any string in it. And we know that when the client receives the answer, the DNS process on that client is going to do something with that answer. We call that process parsing. So the endpoint uses a parser to parse or look into the result and then do something with it. So essentially an attacker, if they have access to the DNS records, as we said earlier, through a compromised registrar or registrar software, they could potentially put content in a text record, which would then be passed by the client and potentially executed as malicious code. And this is a known attack vector. It's typically used as what's called a dropper or a pre-attack. So the text in that record will then start the process, perhaps redirect you to a website or a location where it might download further software, which will be the actual attack itself. So this is quite a worrying concept. And to date, even security manufacturers that provide DNS protection, even in corporate environments, are still not providing any protection for the actual result that comes back from a DNS query. So we need to look at other methods for trying to protect ourselves. And most DNS filters have, for example, a category called malicious. And the way security vendors will try to protect us from record content type attacks is actually stopping us from going to the resulting site in the first place. Secondly, if there's a redirection from a past DNS record, then they will block access to the resulting site for that as well. But it's an interesting concept, and it's something that I think needs some work done on. And we'll see if DNS vendors or DNS filtering vendors in the future come up with some protection for this type of attack vector.
My gosh, that's such an interesting thought to start landing our show with, and something that I would plug is the security methodology that we've been spending so much time on. Well, not methodology, but the security principles that we spend time on, which can iterate into methodology around zero trust. And of course, in terms of zero trust, we apply things like network microsegmentation, which sounds like a lot of effort, but it boils down to understanding what your network is doing and allowing it only to do what it is designed to do to minimize attack. However, coming back to one of the primary tenets of zero trust is that we assume breach, which means that if you are intimidated by the kind of attack vectors that are out there, and you understand that there is no such thing as a perfect defense, and this is why we drill for breach readiness. Well, we should drill for breach readiness, and we've had at least, Chris, 2 shows on breach readiness before, and one of them is just to deal with the fact that you are not impervious to attack. And what are you going to do if or when that day comes? Chris?
Yeah, look, I think that's a really good place to end the show. Obviously now I'm, petrified of text records.
Yes.
Thanks, Robbie. I hadn't considered that.
Thanks, Robbie.
No, but like all seriousness though, I'd seen a session recently when I went to Blue Hat in Israel, where they demonstrated command and control through Spotify, right, and stuff like that. And there's no reason why a DNS text record can't be used as a command and control service for infected clients either. So it is this, scary thought, but I think it reinforces the fact that, DNS is the simple thing that we all rely on, but actually there's a lot more to it. And we probably should be paying attention to how we architect DNS, both in the workplace and at home to protect our privacy just a little bit. So I think we'll leave it there for today. Robby, really, really enjoyed that as always. Thank you very much for kind of laying down your knowledge for us. It was a very, very fascinating chat, and we hope to have you back for a part 3 sometime.
Thank you, Chris. Thank you, Nick.
Yeah, pleasure to have you on the show. And to everyone who's watching or listening, we hope that you stay warm if you're cold, or if you are hot, that you get cold with that.
Or enjoy that.
Enjoy that.
Enjoy being
Thanks for listening to the show, and we'll see you next time. Goodbye.
Thank you. Bye.